All right, without further ado, let's jump into the first module. If you complete watching all the 5 modules, you will receive a certificate of attendance. Please look out for it after 1 week. Let's jump into Module 1, Cloud Concepts. Let's quickly define cloud computing. Computing refers to the on-demand delivery of IT resources and applications via the internet with a pay-as-you-go pricing model. When you are using AWS, you are paying for the time that you are using the resources. For example, if you are running a Linux virtual machine for 3 hours and 40 minutes, you are only paying 3 hours and 40 minutes of usage. Hence, another common term used to describe such on-demand delivery of IT resources is utility computing, as pricing model is conceptually similar to how you are being charged for using electricity or water in your home. Before cloud computing, you would have to provision capacity based on making an educated guess of what your maximum peaks is. If you didn't meet your projected maximum peaks, you would be paying for expensive resources that would stay idle. Conversely, if you underestimate your actual maximum peaks, you have insufficient capacity to meet your needs. Mind you, this is not taking into account the overheads of real estate, power, and cooling associated with running your own data center. With AWS, you are provided a simple way to access servers, databases, storage, and higher-level application components over the internet. These resources or services can be initiated within seconds without you having to do any physical rack and stack. Any of these services is one click or an API call away. Not only can you initiate these IT resources within seconds, you can treat these as temporary and disposable resources, deprovisioning them when you do not require them, freeing you from the inflexibility and constraints of a fixed and finite IT infrastructure. By harnessing the power of AWS Cloud, your approach to change management, testing, reliability, and capacity planning is more agile and efficient. Once you have created your new AWS account via aws.amazon.com, you can sign into the AWS Management Console by this interface. You can sign in with root credentials. However, it is a security best practice to create IAM users and sign in as an IAM user together with the associated password. Once signed in, you are presented with this interface. You can explore the available AWS services, use our Solutions Builder options to quickly get started with AWS, try our helpful tutorials and videos, investigate our helpful tips, and explore other topics all via a single click. You can also provide us with your feedback on the AWS platform, change the console display language, read our privacy policy, and our terms of use. We offer multiple methods for you to locate our services. You can view recently visited services, such as the VPC service, but remember, you can always return home by clicking the cube. There's also a handy service drop-down menu offering access to all services either by alphabetical order or by groupings of related services. You can access your account and billing information or sign out of the console from this menu. You can use the region selection menu to put your focus in the AWS region that you wish to work within for region-scoped services. The support menu provides access to the AWS Support Center, our public forums, our very comprehensive documentations, and information about AWS training and certification offerings. On the menu bar of the Management Console, you'll also find a handy pin tool that lets you drag and drop icons for your frequently used services onto the menu bar. You can reorder these icons to suit your own preferences. Click the pin again to return to normal operations. You can also remove icons if no longer required. Having set up the icons for your frequently used services, they are now only ever a click away. For each service interface, the left side typically presents a navigation menu of options. Having selected an option, you will now see a list pane for objects at the top and a details pane at the bottom, displaying details of the selected items in the list above. The interface changes according to the service that you're working with. There are controls for you to arrange the list and details pane as required. The details for the selected object are typically accessible by a number of tabs. Remember to return to the starting or home screen, just click the cube icon, which is always at the top left-hand corner. The number one reason organizations are moving to the cloud is increased agility. There are three factors that influence agility: speed, experimentation, culture of innovation. Let's take a closer look at how these factors enable organizations to be more agile by harnessing the power of cloud computing. With AWS facilities all over the world, this can offer you global reach within minutes. While it is costly to put your data centers where your customers are, well, with AWS, you can get the benefits without having to make the huge initial investment. In cloud computing, new resources are only a click away, which means you reduce the time it takes to make those resources available to your developers from weeks to just minutes, resulting in a dramatic increase in agility for your organization. Another agility benefit of cloud computing is being able to experiment more often. AWS enables operations as code in the cloud and the ability to safely experiment, develop operational procedures, and practice failure. For example, with AWS, you can spin up servers in minutes for experimenting, return or repurpose servers for other experiments. With virtual and automatable resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. Using services such as AWS CloudFormation enables you to have consistent, templated dev, test, and production environments with increasing levels of operational control. Access to low-cost resources reduces risks and encourages frequent experiments. This is great for IT because it leads to discovery of new configurations and innovations. In order to understand how AWS utilizes the agility of cloud computing, we have to look at the AWS infrastructure that supports elasticity, scalability, and reliability of cloud computing resources. Here are some examples. Elasticity in regards to elastic web scale computing, scalability in regards to scaling your fleet up or down depending on needs, reliability in regards to utilizing a highly reliable environment that AWS offers. Let's review the AWS global infrastructure, which can be broken down into three topics: regions, availability zones or AZs, edge locations. Those orange circles you see on the world map are AWS regions distributed across the globe, and the numbers within are the number of availability zones or AZs in that region. But what is a region? A region is a geographic area that contains two or more availability zones or AZs. Regions are separate entities from one another, and resources in one region are not automatically replicated to other regions. While building and choosing your custom services and features, you have the opportunity to choose in what geographical region your information will be stored. When doing so, it is important to consider which region will help you optimize latency while minimizing costs and adhering to whatever regulatory requirements you may have. Let's dive deeper here on this point. If you are leveraging cloud computing services, you can easily deploy your application in multiple regions. For instance, you can have an application in a region nearest to your headquarters in Singapore. Let's say your largest customer base is located in Melbourne, Australia. With a few clicks, you can easily deploy in the Sydney region to provide a better experience for your customers while minimizing latency and increasing agility for your stations. All of this within minutes and with minimal cost. Given that the AWS platform has more than 105 services as of August 2018, ranging from compute, storage, security, to Internet of Things, IoT, artificial intelligence, AI, how would you choose a region if latency is not an issue? Well, head down to the AWS region table page that lists down the various AWS services available in the regions around the globe. Here, you can sort through Americas, Europe, Middle East, Africa, and finally, Asia Pacific. Notice that the table is broken down even more into specific locations and what services are currently offered there. Now, let's talk about AZs. AZs are a collection of data centers within a specific region. Each are isolated from one another, but yet they are connected together by a fast, low-latency link. So, what exactly is the benefit of having the AZs isolated but also connected? When common points of failure occur, it does not affect all of your AZs because they are isolated. How are they exactly isolated? Each AZ is a physically distinct, independent infrastructure. They are also physically and logically separated. Each AZ has their own discrete, uninterrupted power supply, on-site backup generators, cooling equipment, networking, and connectivity. They are all supplied via different grids from independent utility companies and connected through multiple Tier 1 transit providers. However, all of those details are transparent to you. From your perspective, a single AZ is equivalent to an on-premise data center. Why is this comparison important? By following the AWS best practice and provision your applications and data across 2 or more AZs, you are in effect replicating the operational principles of deploying workloads across 2 fault-isolated data centers in an on-premises design. To deliver content to end users with lower latency, as of August 2018, AWS uses a global network of 114 points of presence, 103 edge locations, and 11 regional edge caches in 56 cities across 24 countries. Regional edge caches are used to optimize caching on the edge locations so that users have a higher probability of accessing information there instead of querying the origin service, resulting in higher latency. All of this optimization is transparent to users. Amazon Cloudfront is a content delivery network, or CDN, service used to deliver content to your customers. Requests for content are automatically routed to the nearest edge location so that the content is delivered faster to the end users. Utilizing the global network of edge locations and regions, you have access to quicker content delivery. Edge locations are typically located in highly populated areas similar to regions and AZs. In addition to Cloudfront, a number of AWS leverages on the edge locations. For example, Amazon Route 53 is a highly available and scalable domain name system, or DNS web service. AWS Shield, which is a managed DDoS protection service. And lastly, AWS WAF, which is a managed web application firewall service. Apart from increasing speed and reducing latency, one of the most important roles of an edge location is offering security at the edge before reaching your data hosted in regions. Using AWS helps customers develop high-performance and reliable solutions to address most business needs. Whether you are offering media services to customers around the world or managing medical devices for a highly decentralized workforce, AWS gives customers the tools to implement solutions quickly and with limited friction. Reliability at AWS is defined as the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. In order to achieve reliability, your architecture and system must have well-planned foundations in place that or down easily, while only paying for actual resources used. Whether you need one virtual server or thousands, whether you need computing resources for a few hours or 24/7, AWS provides an elastic infrastructure to meet your needs. The elastic nature of AWS also accommodates new strategic directions that customers want to follow. AWS offers customers innovative new services. You can easily deploy your system in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. Thanks to the efficiencies of scale that AWS enjoys, you can consistently use innovative services and cutting-edge technology without having to go through multiple procurement cycles and expensive evaluations. AWS provides capabilities to support virtually any workload. This level of innovation gives customers continued access to the latest technology. One of the key benefits for AWS customers is the ability to use services at your own pace. By using AWS and the tools AWS provides, customers can grow, shrink, and adapt their consumptions of services to meet seasonal requirements. AWS also delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications. Using AWS tools like auto-scaling and elastic load balancing, your application can scale up or down based on demand. Backed by AWS massive infrastructure, you have access to compute and storage resources when you need them. We have come to the end of Module 1. Test your knowledge with the following questions. In this module, we are going to look at the AWS Core Amazon Virtual Private Cloud, or VPC. The AWS Cloud offers pay-as-you-go, on-demand compute and managed services, all accessible via the web. These compute resources and services must be accessible via normal IP protocols implemented with familiar network structures. Customers need to adhere to networking best practices and meet regulatory and organizational requirements. Amazon Virtual Private Cloud, or VPC, is a networking AWS service that you will need to meet your networking requirements. Amazon Virtual Private Cloud, or VPC, allows you to create a private network within the AWS cloud that uses many of the steps as an on-premise network. But much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. Amazon Virtual Private Cloud, or VPC, also gives you complete control of the network configuration. You can define normal networking configuration items such as IP addresses, subnets, and routing tables. This allows you to control what you expose to the internet and what you isolate within the Amazon VPC. Amazon VPC builds upon the AWS global infrastructure of regions and AZs and allows you to easily take advantage of the high availability provided by the AWS cloud. It also allows you to provision virtual networks hosted on the AWS cloud dedicated to your AWS account. When you create a VPC, it will span across all the AZs of a single region. Each AWS account can create multiple VPCs that can be used to segregate environments. A VPC defines an IP address space that is then divided by subnets. VPCs are logically isolated from each other. You can create many subnets in a VPC, though fewer is recommended to limit the complexity of the network topology. But this is totally up to you. You can configure route tables for your subnets to control the traffic between subnets and the internet. By default, all subnets within a VPC can communicate with each other. Subnets are generally classified as public or private, with public having direct access to the internet and private not having direct access to the internet. For a subnet to be public, you need to attach an internet gateway to the VPC and update the route table of the public subnet to send non-local traffic to the internet gateway. Amazon Elastic Compute Cloud, or EC2 instances, also must have a public IP address to route to an internet gateway. Let's design an Amazon VPC that you can start deploying compute resources and AWS services. We will create a network that supports high availability and uses multiple subnets. First, because VPC is region-based, you need to select a region, say, the Singapore region. Next, you will need to create a VPC. Let's name it Test VPC, and you will define the IP address space for the VPC. The 10.0.0.0/16 is the classless inter-domain routing or CIDR format and means that you have over 65,000 IP addresses to use in the VPC. Next, you will create a subnet named Subnet A1. We've assigned an IP address space that contains 256 IP addresses, and this subnet will live in AZ-A. Next, you will create another subnet called Subnet B1 and assign it IP address space, however, this time with 512 IP addresses. For the non-networking administrators in the audience, there are plenty of CIDR calculators online that can help you figure out the number of IP addresses in a CIDR range. We have added an internet gateway called Test IGW. Subnet A1 will become a public subnet where workloads can be directly accessed from the internet. Subnet B1 will be your private subnet that is isolated from the internet. For the network administrators in the audience, you may find the network design diagram somewhat familiar. This is because the public subnet will map nicely to your DMZ, and the private subnet will map to your production network in an on-premises environment. Let's summarize what you have learned so far and review some next steps. You have learned about VPCs, internet gateways, and subnets. Next steps in your future learning include other VPC features such as routing tables, VPC endpoints, and peering options. Also, you can learn about deploying AWS resources into your VPC. Let's take a look at AWS Security Groups. Security of the AWS Cloud is one of our highest priorities, and there are many robust security options to help you secure your data in the AWS Cloud. One of the features is Security Groups. At AWS, Security Groups act like a built-in Layer 4 firewall for your virtual servers. With these security groups, you have full control on how accessible your instances are. At the most basic level, it is just another method to filter traffic to your instances. To determine who has access to your instances, you would configure a security group rule. Rules can vary from keeping the instance completely private, totally public, or somewhere in between. Here's an example of a classic AWS multi-tier security group. In this architecture, notice multiple different security group rules have been created to accommodate this multi-tiered web architecture. If you start at the web tier, there is a rule set up to accept traffic from anywhere on the internet on port 80 and 443 by selecting the source of 0.0.0.0/0. Next, if you move to the app tier, there is a security group that only accepts traffic from the web tier. And similarly, the database tier can only accept traffic from the app tier. Finally, there has also been a rule created to allow administration remotely from the corporate network over SSH port 22. The security group configurations follows the least privilege principle, where the access is limited to those that need it and no more than that. We now move on to the next core service, compute. Data centers are expensive to build, staff, and maintain. Hardware are purchased often based upon projected plans, not actual usage. You need to provision resources for the worst case. Your servers must be able to handle traffic spikes and events. Unfortunately, after the build-out, you often have capacity lying idle. AWS offers flexibility and cost-effectiveness. With AWS, you can scale your compute needs to your workload. Scalability is built into our compute services so that as demand increases, you can easily scale up. If demand drops, say, at night or on the weekends, you can scale down to save money and resources. You don't need to pay for what you are not using. Computing needs may change over time, and our Amazon EC2 service, for example, offers a wide variety of instance types appropriate from simple web servers to large machine learning clusters. You are not locked into specific hardware configurations that you have purchased, and can easily change instance types. Amazon EC2 allows you complete flexibility to run applications at any scale. You maintain complete control over your environment, and unlike an on-premises environment with on-demand pricing, you can cost-effectively scale resources up and down to meet your needs. What if, instead of running servers, you could just run your application when needed? AWS Lambda lets you run code without provisioning or manage servers. You pay only for the compute time you consume. There is no charge when your code is not running. With Lambda, you can run code for virtually any type of application or backend service: mobile, Internet of Things, IoT, streaming services, and more, all with zero administration. For example, say I want to process an uploaded image. I can upload the image to Amazon Simple Storage Service, or S3, which is a service that allows you to store and retrieve any amount of data from anywhere, and use an event trigger to launch a Lambda function to process the image without having to have an idle server standing by. Think about it, the ease of running compute without having to provision and maintain servers. It's like switching on the light and having to think about how the power is generated and sent to your home. A great example of utility computing. If you need to run a simple website or e-commerce applications, AWS offers Amazon Lightsail. With Lightsail, you can launch a virtual private server in just minutes and easily manage simple web and application servers. Lightsail includes everything needed to jumpstart your project: a virtual machine, SSD-based storage, data transfer, DNS management, and a static IP address for a low, predictable price. Do you use container services on premises? Amazon Elastic Container Service, Amazon ECS, is a highly scalable, high-performance container management service that supports Docker containers and allows you to easily run applications on a managed cluster of Amazon EC2 instances. Amazon ECS eliminates the need for you to install, operate, and scale your own cluster management infrastructure. AWS Fargate is a technology for Amazon ECS that allows users to run containers without having to manage servers or clusters. It removes the need to interact or think about servers or clusters. Amazon EKS, or Amazon Elastic Container Service for Kubernetes, is a managed service that makes it simple to run Kubernetes on AWS without needing to install or operate your own Kubernetes clusters. Kubernetes is an open source platform that is used for managing containerized applications and workloads. Wow, now that's a lot of compute services to take in. Let's focus on Amazon EC2 that underpins many of the workload that you will be deploying on the AWS platform. First, why is it called Amazon EC2, which stands for Amazon Elastic Compute Cloud? Well, compute refers to the server resources that are being presented. There's a lot of different fun and exciting things you can do with servers, as you can see from the list of server types on the right of the screen. Cloud refers to the fact that these are cloud-hosted compute resources. Elastic refers to the fact that if properly configured, you can increase or decrease the amount of servers required by an application automatically, according to the current demands on that application. But let's stop calling them servers and use the proper name of Amazon EC2 instances. Instances are pay-as-you-go. You pay for running instances and for the time they are running. Provided with Amazon EC2 instances are a broad selection of hardware and software and selection of where to host your instances. If you have been using any kind of hypervisor on premises, an EC2 instance is conceptually similar to a virtual machine. There are many different families of instance types, as you can see from the table above. They are in turn grouped into different broad categories for different use cases, like compute optimized to be used for science and engineering apps, or GPU optimized for machine learning. Here in AWS, we are constantly innovating and pushing out new instance types and newer versions of existing instance types so that you, our customer, benefits from these latest technologies available from our technology partner, Intel. All of the EC2 instances are powered by Intel Xeon processors. And by using Amazon EC2 instances, you have quicker access to the various Intel compute innovation at a click of a button. All you need to do to change or upgrade your EC2 instance hardware is to stop it, pick the instance type and size you want, and start it up. The ease of accessing different EC2 instance types and sizes allow you to use a larger compute resource to complete your job quicker and save you money because you can deprovision it once your job is done. This table shows you for each family of instance type the Intel technology that is supported. Do check out the AWS EC2 product page for the latest information as it gets updated regularly. C5 instances are designed for compute-heavy applications like batch processing, distributed analytics, high-performance computing, ad serving, highly scalable multiplayer gaming, and video encoding. The new instances offer a 25% price-performance improvement over C4 instances, with over 50% for some workloads. They also have additional memory for vCPU and for code that can make use of the new AVX 512 instance twice the performance for vector and floating point workloads. Over the years, we have been working non-stop to provide our customers with the best possible networking, storage, and compute performance, with a long-term focus on offloading many types of work to dedicated hardware designed and built by AWS. The C5 instance type incorporates the latest generation of our hardware offloads and also takes another big step forward with the addition of a new hypervisor that runs hand-in-glove with our hardware. The new hypervisor allows us to give you access to all of the processing power provided by the host hardware while also making performance even more consistent and further raising the bar on security. The general-purpose M instances go all the way back to 2006 when we launched the M1.small. We continued to evolve along this branch of our family tree, launching the M2 in 2009, M3 in 2012, and M4 in 2015. Our customers use the general-purpose instances to run web and app servers, host enterprise applications, support online games, just about any kind of workload you can think of. Currently, M5 instances are the next generation of Amazon EC2 general-purpose instances, powered by 2.5 GHz Intel Xeon Platinum 8000 series processors. With enhanced networking and a new, larger instance size that provides up to 96 vCPUs and 384 gigabytes of memory, M5 instances have up to 50% more vCPUs and memory and 25% more network bandwidth than M4. With all of that compute power, you are going to need to distribute it. Yes? In comes Elastic Load Balancing, or ELB. Elastic Load Balancing, ELB, is a managed load balancing service that distributes incoming application traffic across multiple Amazon EC2 instances. There are currently 3 product offerings: the Application Load Balancer, or ALB, Network Load Balancer, or NLB, and a Classic Load Balancer. Here's a table that broadly compares these 3 types of load balancers. First up is the Application Load Balancer, ALB, that functions at the application level. It supports content-based routing and applications that run in containers. It supports a pair of industry-standard protocols, WebSocket and HTTP2, and can provide additional visibility into the health of the target instances and containers. Then you have Network Load Balancer, NLB, which is designed to handle tens of millions of requests per second while maintaining high throughput at ultra-low latency. Rounding up the pack is a Classic Load Balancer, CLB, that provides the basic load balancing across multiple Amazon EC2 instances and operates at both requests and connection level. We recommend the using of ALB or NLB for workloads running in VPCs. Do check out the Elastic Load Balancing product page for more details and side-by-side comparisons. Application Load Balancer can be used in many scenarios. One is the ability to use containers to host your microservices and route those applications from a single load balancer. Application Load Balancer allows you to route different requests to the same instance but defer the path based on the pod. If you have different containers listening on these pods, you can set up routing rules to distribute traffic to only the desired backend application. Here, you can see how the Application Load Balancer routes and organizes backend targets. While calling the listeners for the load balancer, you create rules to direct how the request received by the load balancer will be routed to the backend targets. To register those targets to the load balancer and configure the health check the load balancer will use for the targets, you create target groups. Targets can also be members of multiple target groups. Depending on how your backend is designed, targets can be either EC2 instances or containers. NLB is optimized to handle sudden and volatile traffic patterns while using a single static IP address per AZ. Because it can handle millions of requests per second while maintaining ultra-low latencies, it is ideal for the applications that require extreme performance. And to complete the compute conversation, we will now touch on auto-scaling. Auto-scaling assists you with designing the desired number of Amazon EC2 instances you want to handle the load for your application. Using auto-scaling removes the guesswork of how many EC2 instances you must have at a point in time to meet your workload requirements. When you run your applications on EC2 instances, it is critical to monitor the performance of your workload using Amazon CloudWatch. CloudWatch by itself, however, will not add or remove EC2 instances. This is where auto-scaling comes into the picture. With Amazon EC2 auto-scaling, you can maintain the health and availability of your fleet. Also dynamically scale your EC2 instances to meet demands during spikes and lulls. Let's look at an example workload. You could use CloudWatch to measure EC2 resource requirements over a standard week. Note that the resource requirements vary, with Wednesday requiring the most capacity and Saturday the least. If you allocate enough EC2 capacity to handle your highest demand time, in this case Wednesday, it means that you are over-provisioning most of the week. This is not a cost-optimized option. On the other hand, you could allocate fewer EC2 instances, thus reducing costs. This could mean that you are under capacity on certain days. And if you don't solve your capacity problem, your application could underperform, or potentially even timeout for your user. Auto-scaling allows you to add or remove EC2 instances based on conditions that you specify. Auto-scaling is especially powerful in environments with fluctuating performance requirements. This allows you to maintain performance and minimize costs. So auto-scaling really answers two critical questions. How can I make sure that my workload has enough EC2 resources to meet fluctuating performance requirements? And how can EC2 resource provisioning occur on demand? Auto-scaling matches up with two AWS best practices. Make your environment scalable and automate as much as possible. Let's take a look at auto-scaling a little closer. So what exactly is meant by scaling? The first thing you have to do is define the conditions for scaling out and scaling in. Auto-scaling can automatically adjust the number of EC2 instances running in your workload based on either conditions that you defined, for example, CPU utilization over 80%, or a schedule. If auto-scaling adds more instances, this is termed scaling out. This is represented by the middle diagram where the ELB is load balancing 3 EC2 instances. The instance highlighted by the green box represents the third instance added to the auto-scaling group compared to the base configuration. As auto-scaling terminates instances, this is an example of scaling in. This is represented by the diagram on the right, where one of the instances has been terminated, resulting in only 2 instances in the auto-scaling group. Remember that you have control as to what initiates these events. So, how do you automatically scale? There are 3 components required for scaling. First, you create a launch configuration. Second, you create an auto-scaling group. And finally, you define at least one auto-scaling policy. Let's take a closer look at what each of these components do. A launch configuration defines what will be launched by auto-scaling. Think of all the things that you would specify when you launch an EC2 instance from the console. These include which Amazon machine image to use, what instance type, security groups, or roles to apply to the instance. What is an auto-scaling group? This is about defining where the deployment takes place and some boundaries for the deployment. This is where you define which VPC and subnets to deploy instances, which load balancer to interact with. You also specify the boundaries for a group. If you set a minimum of 2 and your server count goes below 2, another instance will be launched to replace it. If you set the maximum of 8, there will never be more than 8 instances in your group. The desired capacity is the number of EC2 instances that you want now. Lastly, what is an auto-scaling policy? This is about specifying when to launch or terminate EC2 instances. You can schedule auto-scaling every Thursday at 3 p.m., for example, or create conditions, if met, to trigger adding or removing instances. Condition-based policies make your auto-scaling dynamic and can meet fluctuating requirements. It is best practice to create at least one auto-scaling policy to specify when to scale out, and at least one policy to specify when to scale in. So how does dynamic auto-scaling work? One common configuration is to create CloudWatch alarms based on performance information from your EC2 instances or a load balancer. As a performance threshold is breached, a CloudWatch alarm triggers an auto-scaling event which either scales out or scales in EC2 instances in the environment. Briefly, CloudWatch is a monitoring service used to collect performance statistics like EC2 instance CPU utilization and turn them into matrices to be monitored. For example, if you are monitoring CPU utilization of an EC2 instance using CloudWatch and have an alarm set to trigger if the utilization is set above 60%. If the alarm is triggered, CloudWatch will execute the auto-scaling policy to add one or more EC2 instances to the auto-scaling group. Auto-scaling will inform ELB to register the new EC2 instance and start sending requests to it. The same principle applies for scaling in. The first part of the alarm is a condition with a specific threshold. In this case, CPU utilization is greater than 80%. Note there is also a time period specified that you can control. This means you could be specifying that the alarm will fire up if CPU utilization is over 80% for 5 consecutive minutes. The time period is critical because you don't want auto-scaling to trigger new instances because your processor spiked for 30 seconds. The second part of the alarm is the action to perform after the alarm is triggered. With auto-scaling, the action could be to add or remove instances. So in this example, if the CPU is over 80% for one consecutive period, 5 minutes by default, auto-scaling will add 2 new instances to the auto-scaling group. When you add more instances, the CPU utilization should go down. You should set another CloudWatch alarm to define a threshold as to when instances should be terminated from the auto-scaling group. As an example, as CPU utilization goes below 20% for more than 5 consecutive minutes, terminate one instance. The beauty of it all is that auto-scaling can manage your workload dynamically, so you do not have to focus on it. Let's summarize what you have learned. Auto-scaling allows you to add or remove EC2 instances based on conditions that you specify. Auto-scaling is especially powerful in environments with fluctuating performance requirements. This allows you to maintain performance and minimize costs. Best of all, this process can scale in or out EC2 instances in the middle of the night while you are sleeping. The 3 core components you must have are a launch configuration, what you like to deploy, an auto-scaling group, where you would like to deploy, and an auto-scaling policy, when you would like to deploy. Remember, every AWS service that you learned about is another tool to build solutions. Now, into one of my favorite topics, storage. And first up is Amazon Elastic Block Store, or EBS. Think of Amazon Elastic Block Store, or EBS volumes, as an actual hard drive that can be used as a storage unit for your Amazon EC2 instance. So whenever you think you must have disk space for your instances running on AWS, you can use them. These volumes can be hard drive or SSD devices, and you pay as you use them. So whenever you don't need a volume anymore, you can just delete it. Amazon Elastic Block Store, or EBS volumes, are designed for being durable and available. This means that the data in a volume is automatically replicated across multiple servers running in the AZ. I made a comparison about EBS volumes and physical media devices like hard drives or SSDs for the ease of understanding. But it's actually more durable than that because of the block-level replication. While creating an EBS volume, you can select the type of storage that best fits your needs. You can choose between magnetic or SSD based on your performance and price requirements. It is all about choosing the right tool for the right job. So for example, if you're running a database instance, you can configure the database to use a secondary volume using SSD for data, which may perform faster than the volume assigned to the operating system. Or you can assign a magnetic volume for the logs because magnetic is cheaper. To provide an even higher level of data durability, Amazon EBS gives you the ability to create point-in-time snapshots, and AWS allows you to recreate a new volume from a snapshot at any time. Share or even copy snapshots to different AWS regions for even greater disaster recovery protection. You can, for example, share your snapshots from the Singapore to the Tokyo region. You can also have encrypted EBS volumes at no additional costs. The encryption occurs on the EC2 side, so the data moving between the EC2 and the EBS volume inside AWS data centers will be encrypted in transit. When your company grows, the amount of data stored on your EBS volumes will probably also grow. EBS volumes have the ability to increase capacity and change different types, meaning that you can change from hard drive to SSD or increase from a 50 gigabyte volume to a 16 terabyte volume. And this resizing operation can be done on the fly without having to stop the instances. And that's it. In summary, we have reviewed what EBS volumes are and its various characteristics. We will next take a look at one of our oldest AWS service, Amazon Simple Storage Service, or S3. Amazon Simple Storage Service, or S3, is a fully managed storage that provides a simple API for storing and retrieving data. You don't have to manage any infra yourself and can put as many objects into S3 as you want. S3 holds trillions of objects and regularly peaks at millions of requests per second. Objects can be almost any data file, such as videos or server logs. S3 supports objects as large as 5 terabytes in size. You could even store database snapshots as objects. Amazon S3 also provides low latency access to the data over the internet by HTTP or HTTPS, so you can retrieve data anytime, anywhere. You can also access S3 privately through a virtual private cloud endpoint. You get fine-grained control over who can access your data using identity and access management, or IAM policies, S3 bucket policies, and even per object access control lists. By default, none of your data is shared publicly. You can also encrypt your data in transit and choose to enable server-side encryption on your objects. Let's take a file that needs to be stored in S3, such as a welcome video. First, you have to create a bucket whose name must be globally unique in Amazon S3 service. This is because the bucket name is used to form a unique URL that you can use to access the bucket. When you want to put this welcome video into the bucket as an object, you can do so by uploading it into the bucket via the management console with a click of a button. The name of the file, welcome.mp4, is now the key that you will reference as part of the URL to access the actual object in the S3 bucket. The sample URL has been color-coded to highlight where the bucket name and key come together, unique URL used to access the video. You can access S3 by the Management Console, AWS CLI, or AWS SDK. Additionally, you can also access the data in your bucket directly via REST endpoints. These support HTTP or HTTPS access. This flexibility to store virtually unlimited amount of data and access that data from anywhere makes the S3 suitable for a wide range of scenarios. As a location for any application data, S3 buckets provide that shared location for storing objects that any instance of your application can access, including applications on EC2 instances or on-premises servers. This can be useful for user-generated media files, server logs, or other files your application needs to store in a common location. Also, because the content can be fetched directly over the web, you can offload serving that content from your application and allow clients to directly fetch the data themselves from S3. For static web hosting, S3 buckets can serve up the static content of your website, including HTML, CSS, JavaScript, and other files. S3 is designed for 11 nines of durability, which makes it a good candidate to store backups of your data. For even greater availability and disaster recovery capability, S3 can even be configured to support cross-region replication such that data put into an S3 bucket in one region can be automatically replicated to another S3 region. The scalable storage and performance of S3 make it a great candidate for staging or long-term storage of data you plan to analyze using a variety of big data tools. In summary, we have taken a quick look at Amazon S3, touched on some of its characteristics like high durability, accessibility, security controls, and some common use cases. Right, so now we're going to log in your demo user called S3 Demo into the AWS Management Console. Once in, we're going to click on the S3 in the navigation bar at the top of the page, which will drop us into the Amazon S3 console. Now I'm going to create a bucket using S3 Demo as the name. And I'm going to drop it in the Singapore region, leaving everything else as default. When I try to click the Create button, it gives me an error message saying that the bucket name already exists. Now, it really doesn't matter which region I select now, because the bucket name must be unique across the AWS infrastructure. So I'm going to change the name to something else. And I'm going to still select the Singapore region. As you can see, it is now succeeded. Next, I'm going to upload an object into this demo bucket. Clicking on Upload, Add Files, and I'll select a file randomly from my laptop. And this happens to be an image. And I'll click on Upload, and it now appears in my bucket. Selecting the target Tiger JPEG, I can see this particular object has a unique URL which I can select and try to access it. But as you can see, I receive an access denied error message because by default, all buckets are not public. I can very easily make this particular image publicly accessible by clicking the Make Public button and refreshing that same tab. You will now see the image I've uploaded. That ends the very short and simple demonstration of creating S3 bucket and uploading an object. We shift gears now and look at different AWS database services. Coming up is Amazon Relational Database Service, or RDS. Let's first take a look at the challenges of running a standalone relational database. As you run your own database, you are responsible for several administrative tasks like server maintenance, OS and software installation, as well as patching, backups, ensuring high availability, scalability, planning, and data security. All these tasks take resources away from other items on your to-do list and requires expertise in several areas. To address the challenges that come with running your own relational database, AWS provides a service that sets up, operates, and scales the relational database without any ongoing administration. Amazon Relational Database Service, or RDS, provides cost-efficient and resizable capacity while automating time-consuming administrative tasks like the ones we have previously covered. Amazon Relational Database Service, or RDS, frees you to focus on your application so you can give them the performance, high availability, security, and compatibility they must have. With Amazon RDS, your primary focus becomes your data and optimizing your application. Amazon RDS manages operating system installation and patching, database installation and patching, automatic backups, and high availability. Scaling resources, managing power and servers, and performing maintenance is also covered by AWS. In short, all of the undifferentiated heavy lifting is offloaded to managed Amazon RDS service, reducing your operational workload and the costs associated with your relational database. Now let's go through an overview of the service and a few potential use cases. The basic building block of Amazon RDS is the database instance. A database instance is an isolated database environment that can contain multiple user-created databases and can be accessed by using the same tools and applications that you use with a standalone database server. The resources found in the database instance can be determined by its database instance class, and type of storage is dictated by the type of drives. Database instances and storage differ in performance characteristics and price, allowing you to tailor your performance and costs to the needs of your database. When you choose to create a database instance, you first have to specify which database engine to run. Amazon RDS currently supports 6 database engines: MySQL, Amazon Aurora, Microsoft SQL Server, PostgreSQL, MariaDB, and Oracle. You deploy an Amazon RDS instance in a VPC of your choice, giving you control over your virtual networking environment. One of the most powerful features of Amazon RDS is the ability to configure your database instance for high availability with a multi-AZ deployment. After configuration, Amazon RDS automatically generates a standby copy of the database instance in another AZ within the same Amazon VPC. After seeding the database copy, transactions are synchronously replicated to the standby copy. Running a database instance with multi-AZ can enhance availability during planned system maintenance and help protect your databases against database instance failure and AZ disruptions. If the master database instance fails, Amazon RDS automatically brings the standby database instance online as the new master. Due to the synchronous replication, there should be no data loss. As the applications refer the database by name using RDS DNS endpoint, you don't have to change anything in application code to use the standby copy for failover. Amazon RDS also supports the creation of read replicas for MySQL, MariaDB, PostgreSQL, and Amazon Aurora. Updates made to the source database instance are asynchronously copied to the read replica instance. you can reduce the load on your source database instance by routing read queries from applications to the read replica. Using read replicas, you can also scale out beyond the capacity constraints of a single database instance for read-heavy database workloads. Read replicas can also be promoted to become the master database instance. But because of the asynchronous replication, this requires manual action. Read replicas can be created in a different region as a new master database. This feature can help satisfy disaster recovery requirements or cutting down on latency by directing reads to read replica closer to the user. Amazon RDS supports the more demanding database applications. You can choose between two SSD-backed storage options, one optimized for high-performance OLTP applications, and the other for cost-effective general-purpose use. With Amazon RDS, you can scale your database compute and storage resources, no downtime, and use the AWS Management Console, the Amazon RDS command line, or simple API calls to manage the service. Amazon RDS runs on the same highly reliable infrastructure used by other AWS services. It also lets you run your instances in your VPC, which provides you with control and security. Now let's take a look at a managed NoSQL database service, Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL non-relational database service. AWS manages all of the underlying data infrastructure for this service and redundantly stores data across multiple facilities within a region as part of the fault-tolerant architecture. With DynamoDB, create tables and items. You can add items to a table. For the DB administrators out there, an item in a DynamoDB table is similar to a row in the RDBMS table. The DynamoDB service automatically partitions your table and has tables in a table. Some customers have production tables that contain billions of items. One of the benefits of a NoSQL database, items in the same table may have different attributes. This gives you the flexibility to add attributes as the application evolves. You can have newer format items stored side by side with older format items in the same table without having to perform schema migrations. Again, for the DB administrators out there, attributes in DynamoDB are similar to columns in an RDBMS table. As your application becomes more popular and as users continue to interact with it, the DynamoDB table can grow with your application needs. All of the data in DynamoDB is stored on solid-state drives, and a simple query language allows for consistent, low-latency query performance. In addition to scaling storage, DynamoDB also allows you to provision the amount of read or write throughput you have to have for your table. When the number of application users grow, DynamoDB tables can be manually scaled to handle the increased number of reads and writes requests with manual provisioning. Alternatively, you can enable auto-scaling so DynamoDB monitors the load on the table and automatically increases or decreases the provision throughput. Some additional key differentiating features include global tables that enables you to automatically replicate across your choice of AWS regions, encryption at rest, and item TTL. The ability to scale your tables in terms of both storage and provision throughput makes Amazon DynamoDB a good fit for structured data from the web, mobile, and Internet of Things applications. For instance, you may have a large number of clients continuously generating data and making large numbers of requests per second. In this case, the throughput scaling of DB allows consistent performance for your clients. DynamoDB is also used in latency-sensitive applications. The predictable query performance, even in large tables, makes it useful for cases where variable latency could cause significant impact to the user experience or to business goals such as ad tech or gaming. Table data is partitioned and indexed by primary key. There are two ways of retrieving data from a DynamoDB table. The first method is the query operation that takes advantage of the partitioning to effectively locate items by using the primary key. The second method is via a scan, which will allow you to locate items in the table by matching conditions on non-key attributes. The second method gives you flexibility to locate items by other attributes. However, the operation is less efficient as DynamoDB will scan through all the items in the table to find the ones that match your criteria. To take full advantage of query operations and DynamoDB, it's important to think about the key you use to uniquely identify items in a DynamoDB table. You can set up a simple primary key based on a single attribute of the data values with a uniform distribution, such as the GUID or other random identifiers. For example, if you were to model a table with products, you could use some attributes, such as the product ID, that would be the table on the left. Alternatively, you can specify a compound key, which would be composed of a partition key and a sort key. That would be the table on the right. In this example, if I was to have a table on songs, I might use the combination of song title and singer to uniquely identify table items. In summary, Amazon DynamoDB is a managed NoSQL database service which can be used as a data store for applications which need to scale to store large amounts of data, support high request volume, and require low latency query performance. We have come to the end of Module 2. Test your knowledge with the following questions. Now that we've done a walkthrough of the AWS core services on the AWS platform, it is time to take a look at security. In this module, we will introduce AWS Security, explain what is the AWS Shared Responsibility Model, how to control and manage access to AWS services in your account, and some of the security resources and features available on the AWS platform. Introduction to AWS Security. AWS delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications, helping to protect the confidentiality, integrity, and availability of your systems and data is of the utmost importance to AWS, as is maintaining customer trust and confidence. This module is intended to introduce AWS approach to security, including the controls in the AWS environment and some of the products and features that AWS makes available to customers to meet their security objectives. All AWS customers benefit from a data center and network architecture built to satisfy the requirements of our most security-sensitive customers. This means that you get a resilient infrastructure designed for high security without the capital outlay and operational overhead of a traditional data center. The AWS infrastructure puts strong safeguards in place to help protect customer privacy. AWS innovates rapidly at scale, continually incorporating customer feedback into AWS services. This continual improvement benefits all customers because AWS solutions improve over time, including constantly evolving core security services such as identity and access management, logging and monitoring, encryption and key management, network segmentation, and standard DDoS protection at little to no additional cost. You also get advanced security services invented by engineers with deep insight into global security trends, allowing your team to proactively address emerging risks in real time while paying for only what you use, all at a lower cost. This means you can choose the security that meets your needs as you grow, without upfront expenses and with much lower operational overhead when compared to managing your own infrastructure. A properly secured environment helps to create a compliant environment. When you migrate your regulated workloads to AWS Cloud, you can achieve a high level of security at scale by using our many governance-enabling features. Cloud-based governance offers a lower cost of entry, easier operations, and improved agility by providing more oversight, security control, and central automation. AWS and its partners offer a wide range of tools and features to help you to meet your security objectives. These tools mirror the familiar controls you deploy within your own on-premises environments. AWS provides security-specific tools and features across network security, configuration management, access control, and data security. In addition, AWS provides monitoring and logging tools, which gives full visibility into what is happening in your environment. AWS provides several security capabilities and services to increase privacy and control network access. These include built-in firewalls that allow you to create private networks within AWS and control network access to your instances and subnets. For example, the security groups that we have covered in the earlier part of this course. Encryption in transit with TLS across all services. Connectivity options that enable dedicated connections from your office or on-premises environment to AWS, which are called AWS Direct Connect. DDoS mitigation technologies as part of your content delivery strategy. AWS offers a range of tools to allow you to move fast while still enabling you to design your cloud resources to comply with organizational standards and best practices. These include deployment tools to manage the creation and decommissioning of AWS resources according to organization standards. Inventory and configuration management tools to identify AWS resources and then track and manage changes to those resources over time. Template definition and management tools to create standard, pre-configured, hardened virtual machines for EC2 instances. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. Data encryption capabilities are available in AWS storage and database services such as Amazon EBS, Amazon S3, Amazon Glacier, Amazon RDS, and Amazon DynamoDB. Flexible key management options allow you to choose whether to have AWS manage the encryption keys or for customers to maintain complete control over their keys. AWS Key Management Service, or KMS, is a managed service that makes it easy for you to create and control the encryption keys used to encrypt your data. It is integrated with AWS CloudTrail to provide you with logs of all key usage to help meet your regulatory and compliance needs. Dedicated hardware-based cryptographic key storage options are available for customers to help satisfy compliance requirements. AWS Cloud Hsm is a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on the AWS cloud where you, the customer, owns the root of trust. In addition, AWS provides APIs for you to integrate encryption and data protection with any of the services you develop or deploy in an AWS environment. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. AWS Identity and Access Management, IAM, is a role-based access control service that manages administrative access to the AWS services available in the AWS account. Multi-factor authentication, MFA, adds extra security because it requires users to type a unique authentication code from an approved authentication device. With Federation, you can use single sign-on, SSO, to access your AWS accounts using credentials from your corporate directory. Amazon Cognito lets you easily add user sign-up and authentication to your mobile and web apps. It enables authentication of users through an external identity provider and provide temporary secure credentials to access your app's backend resources. AWS SSO is a service that makes it easy to centrally manage SSO access to multiple AWS accounts and business applications. With AWS SSO, you can manage SSO access and user permissions to all of your accounts centrally. AWS provides tools and features that enable you to see what's happening in your AWS environment. These include AWS CloudTrail that provides visibility into API calls, including who, what, when, and from where calls were made. Amazon CloudWatch Logs for log aggregation and options, streamlining investigations and compliance reporting. Amazon CloudWatch Alarms to send notifications when specific events occur or thresholds are exceeded. These tools and features give you the visibility you must have to spot issues before they impact the business and allow you to improve security posture and reduce the risk profile of your environment. What if you want to make use of the same tools you have been using in your on-premises environment on the AWS platform? The AWS Marketplace offers hundreds of industry-leading partner products that are equivalent, identical to, or integrate with existing controls in your on-premises environments, including anti-malware web application firewalls and intrusion protection. These products complement the tools and features offered by AWS to enable you to deploy a comprehensive security architecture and a more seamless experience across your cloud and on-premises environments. What is the AWS Shared Responsibility Model? After the customer starts using the AWS platform, AWS shares the responsibility of securing the data in AWS with its customers. This concept is known as the AWS Shared Responsibility Model. Let's take a look at what AWS is responsible for and what the customer is responsible for in this model. AWS is responsible for what is known as security of the cloud. What does that mean? Under the shared responsibility model, AWS operates, manages, and controls the components from the host operating system and the virtualization layer down to the physical security of the facilities in which the services operate. It means that AWS is responsible for protecting the global infrastructure that runs all of the services offered in the AWS cloud, which include regions, AZs, and edge locations. Protecting this infrastructure is AWS' #1 priority, and while you can't visit AWS data centers or offices to see this protection firsthand, AWS provides several reports from third-party auditors who have verified our compliance with a variety of computer security standards and regulations. Note that in addition to protecting this global infrastructure, AWS is responsible for the security configurations of its products that are considered foundational or managed services, which include compute, storage, database, and networking. Examples of these types of services include Amazon DynamoDB, Amazon RDS, Amazon Redshift, Amazon Elastic MapReduce, Amazon Workspaces. While the cloud infrastructure is secured and maintained by AWS, customers are responsible for security of everything they put in the cloud. When using AWS services, customers maintain complete control over their content and are responsible for managing critical content security requirements, including what content they choose to store on AWS, which AWS services are used with the content, in what country that content is stored, the format and structure of that content, and whether it is masked, anonymized, or encrypted, who has access to that content, and how those access rights are granted, managed, and revoked, who has administrative rights to the AWS services available in the AWS account. Customers get to retain control of what security they choose to implement to protect their own data, platform, identity and access management, applications, and operating systems. That includes patching their guest OS and applications. This basically means that the shared responsibility model changes depending on the AWS service the customer uses. One of the key AWS security service is Identity and Access Management, which is the next service we are looking at. AWS IAM is a service that helps you securely control access to AWS resources for your users. You use AWS IAM to control who can use your AWS resources, this is known as authentication, and how they can use resources, known as authorization. AWS IAM allows you to manage access to compute, storage, database, and application services in the AWS cloud. In short, this is the role-based access control or RBAC mechanism to manage access on the AWS platform. Think of the access control concepts you are already familiar with, such as users. Think of these as your end users. Groups, think of these as a collection of users by job function. Permissions, which can be applied to users or groups. And roles, think of these as trusted entities. That's exactly what AWS IAM uses, which makes it so powerful. Using AWS IAM, you can create and manage AWS users and groups and use You can create users in the AWS IAM, assign them individual security credentials, in other words, access keys, passwords, and multi-factor authentication devices, or request temporary security credentials to provide users access to AWS resources and services. You can manage permissions to control which operations a user can perform. Next, manage AWS IAM roles and their permissions. You can create roles in AWS IAM and manage permissions to control which operations can be performed by the entity or AWS service that assumes the role. Finally, manage federated users and their permissions. You can enable identity federation to allow existing identities like users, groups, and roles from your corporate directory to access the AWS Management Console, call AWS APIs, and access resources without the need to create an IAM user for each identity. When you first create an AWS account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user and is accessed by signing in with the email address and password that you used to create the account. Because you can't restrict permissions for root user credentials, it is recommended that you delete your root user access keys. If you require administrator-level permissions, create an IAM user, grant that user full administrator access, and then use those credentials to interact with AWS. If you need to modify or revoke your permissions, you can delete or modify the policies that are associated with that IAM user. When adding users, you get to select how users will access AWS. There are two different types of access you can assign users: programmatic access and AWS Management Console access. Programmatic access enables an access key ID and secret access key for the AWS API, CLI, SDK, and other development tools. The other option is to give AWS Management Console access authenticated, they then have to be authorized to access an AWS service. To assign permission to a user, group, or role, you have to create a policy, which is a document that explicitly lists permissions. It is important to note, as depicted in the diagram, that one policy can be assigned to an IAM user, IAM group, and IAM roles. On the AWS Management Console, we click on IAM to the left of your screen. On the AWS IAM console, we have a few options to choose from. Let's click on Policies. Here, you see the AWS Managed Policies. Let us create a policy using the AWS Policy Generator wizard. We start with the Allow option and choose Amazon S3 under AWS Services. Under Actions, we could allow all list operations. Rather than selecting all the list operations, let us select one for now and update the policy later. Under Amazon Resource Name, we use the wildcard character. On the Amazon S3 console, we have a bucket which contains a folder labeled Pic. The folder contains a picture, and the same picture is also stored on the root of the bucket. Let's create a second statement, AWS IAM for Amazon S3. Under Action, let's choose the GET object operation to permit download. For Amazon Resource Name, or ARN, let's follow the documentation to learn more about the structure. The ARN always starts with ARN, followed by AWS, and a service in use. In our example, we will use S3, followed by the bucket name, /folder, and /star to indicate all objects under the policy. Now let's create a for Amazon EC2. Under Actions, we will select all Describe and Get actions, along with the options to start and stop instances. Finally, under ARN, let's use star to indicate all instances and click on Next Step. Let's give the policy a name, a description, and let's replace S3:list bucket with S3:list star, which indicates all list operations. We then validate the policy and create the policy. The policy can be listed using the Customer Managed filter. Let's create a group called Team1 and attach the policy we created earlier. After we create the group, we proceed to create users. Because the user 1 will only need console access, we select the appropriate option. The user is provided with the password and now can be prompted to enter a new password if needed. We now add the user to the group, making sure they have the right permissions. Login details can also be emailed to the user. For this example, we will copy the login URL and use another browser to simulate the new user login. Notice the AWS account is specified and the user only enters the login credentials. After logging in, let's go to the Amazon EC2 console and then to the Instance option to find the list of instances. If the user tries to terminate an instance, they get an unauthorized error message. However, if the user tries to start an instance, as per the policy, it should be successful. Similarly, a stop operation should also be permitted. Let's now move to the Amazon S3 console. As per the policy, the user should be permitted to list all the buckets and their contents. But any option to download objects should fail unless it is a public folder in the demo bucket. Any option as expected, the picture was walk through some of the best practices of AWS IAM. Delete your AWS root account access keys because they provide unrestricted access to your AWS resources. Instead, use IAM user access keys or temporary security credentials. Activate multi-factor authentication, or MFA, on your AWS root account to add another layer of protection to keep your account secure. Create IAM users and give them only the permissions they have to have. Do not use your AWS root account for day-to-day interaction with AWS because the root account provides unrestricted access to your AWS resources. Use IAM groups to assign permissions to your IAM users to simplify managing and auditing permissions in your account. Apply an IAM password policy to require your IAM users to create strong passwords and to rotate their passwords regularly. Use roles for applications that run on Amazon EC2 instances instead of storing credentials in the instances. Delegate by using roles instead of by sharing credentials. For example, this can be used to temporarily grant access to an IAM user from AWS account A to AWS account B without having to create another IAM user in account B. Rotate credentials regularly. Remove unnecessary users and credentials. Use policy conditions for extra security. For example, you can restrict certain actions that modify or delete existing settings to only when the login is via MFA. Lastly, monitor activity in your AWS account using AWS CloudTrail. We have come to the end of Module 3. Test your knowledge with the following questions. critically think about their architecture. The framework helps you to determine whether your infrastructure follows best practices. With that, AWS has developed a guide to help you with the design of your architecture from 5 different perspectives or pillars. The pillars are security, reliability, performance efficiency, cost optimization, and operational excellence. Let's go into more details. The security pillar encompasses the ability to protect your information, systems, and assets. It accomplishes this while delivering business value through risk assessments and mitigating strategies. To dive a little deeper here, cloud security is comprised of 5 areas. Let's briefly look into each area. Identity and access management, which is critical to make sure that only authorized and authenticated users can access your resources and only in the manner you intend. There are also detective controls, which can be used to identify a potential security incident by considering some approaches such as capturing, analyzing logs, and integrating auditing controls. Infrastructure protection. This is designed to ensure systems and services within your architecture are protected against unintended and unauthorized access. For instance, the user can create network boundaries, hardening and patching OSs, users, keys, access levels, and application firewalls or gateways. With data protection, there are numerous approaches and methods to consider. Some of them include data classification, encryption, protecting data at rest and in transit, data backup, replication and recovery when needed. Incident response. Even with all the preventive and detective measures, organizations should still create an incident response process to respond to and mitigate any potential security incidents. Incident response is designed to keep your architecture updated to accommodate a timely investigation and recovery. When you are architecting, it's important to consider specific design principles to help you strengthen your security. Apply security at all layers. You want to have multiple layers of defense by securing your infrastructure everywhere and at every layer. In a physical data center, security is typically considered only at the perimeter. With AWS, you can implement security at the perimeter and within and between your resources. This is designed to assist with your individual environment and components that they are secured from each other as well. Next, enable traceability. Through logging and auditing all actions or changes to your environment. Another useful design principle is the principle of least privilege. Make sure that authorization within your environment is adequate and that you are implementing strong logical access controls to your AWS resources, granting minimal privileges for business requirements. Next, focus on securing your system. With the AWS Shared Responsibility model, you can focus clearly on securing your application, data, and operating systems, while AWS provides secure infrastructure and services. Finally, automate security best practices. Software-based security mechanisms improve your ability to securely scale more rapidly and cost-effectively. For example, create and save a patched, hardened image of a virtual server so that when you need an image, you can use that image automatically to create a new instance. Another best practice is to automate the response to both routine and anonymous security events. The focus with the reliability pillar is that it encompasses the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. The bottom line is that reliability is there to assist in the ability to recover from failures and meet demand. Reliability in the cloud is composed of three areas: foundations, change management, failure management. In order to achieve reliability, your architecture and system must have well-planned foundation in place that can handle changes in demand or with requirements, and also detect failure and automatically self-heal. Before architecting any sort of structure, it is critical to look at the foundation before construction. Similarly, in the cloud, before architecting any system, foundational requirements that influence reliability should be in place. With change management, it is really important to fully understand and be aware of how change can affect your system. If you plan proactively and monitor your systems, you can accommodate and adjust to change quickly and reliably. To really make sure your architecture is reliable, it is key to anticipate, be aware, respond, and prevent failures from happening. In a cloud environment, you can take advantage of automation with monitoring, replace systems in your environment, and later troubleshoot failed systems all at low cost, and all while still being reliable. The design principles that can increase reliability include testing recovery procedures. In the cloud, users have the ability to test how systems fail and can validate their recovery procedures. Users can simulate and expose different failures and then rectify before a real failure occurs. Automatically recover from failure. In AWS, users can trigger automated responses when thresholds are breached. This makes it possible to anticipate and remediate failures before they occur. Scale horizontally to increase aggregate system availability. When you have one large resource, it is beneficial to replace that large resource with multiple small resources to reduce the impact of a single point of failure on the overall system. Scale horizontally and distribute requests among the multiple small resources. Stop guessing capacity. In the cloud environment, you have the ability to monitor demand and systems utilization and automate the addition or removal of resources. This is designed to make sure you have the optimal level to satisfy your demand without over or under provisioning. Manage change in automation. Changes to your architectures and infrastructure should be made using automation. With this, you only need to manage change through your automation, not every single system or resource. Now let's look at the performance efficiency pillar. The four pieces that make up performance efficiency in the cloud include selection, review, monitoring, trade-offs. Let's dive deeper into each area. With selection, it is important to choose the best solution that will optimize your architecture. However, these solutions vary based on the kind of workload you have. With AWS, resources are virtualized and allow you to customize your solutions in many different types and configurations. With Review, you can continuously innovate your solutions and take advantage of the newer technologies and approaches that become available. Any of these newly released services or features can improve the performance efficiency of your architecture. With regards to monitoring, after you have implemented your architecture, you will need to monitor performance to verify that you can remediate any issues before customers are affected and aware of them. With AWS, you can use automation and monitor your architecture with tools such as Amazon CloudWatch, Amazon Simple Queue Service, and AWS Lambda. Finally, there are trade-offs. An example of a trade-off is trading consistency, durability, and space versus time or latency to deliver higher performance. Now let's look at the design principles that can help you achieve performance efficiency. First, democratize advanced technologies. Technologies that are difficult to implement can become simpler to consume by pushing that knowledge and complexity into the cloud vendor's domain. Instead of having your IT team learn how to host and run the new technology, they can consume it as a service. Then you have going global in minutes. With AWS, you can easily deploy your systems in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. The next design principle that can help you achieve performance efficiency is to use a serverless architecture. In the cloud, you remove the need to run and maintain traditional server for compute activities. This also removes the operational burden and can lower transactional costs. Another design principle is to experiment more often. With virtualization, you can quickly carry out testing to enhance efficiency. Finally, there's mathematical sympathy. This principle has suggestions to use the technology approach that best aligns to what you are trying to achieve. Essentially, use the tool or service that best suits your needs. Our next pillar is the cost optimization pillar, which includes the continual process of refinement and improvement of a system throughout its entire life cycle. This pillar encompasses the idea that you can build and operate cost-aware systems and maximize its return on investment. The four areas that make up the cost optimization pillar include cost-effective resources, matching supply with demand, expenditure awareness, and finally, optimizing over time. A fully cost-optimized system will use all resources it has to achieve the best outcome at the lowest possible price point, all while still meeting your functional requirements. Making sure that your systems are using the appropriate services, resources, and configurations is one of the key parts to cost savings. As a user, you want to focus on the details such as provisioning, sizing, purchasing options, and other specifics to design the best architecture for your needs. Another component to cost optimization is matching your supply with your demand. With AWS Cloud, you can leverage the elasticity of the cloud architecture to meet demands as they change. You can auto-scale and be notified by other services to adjust your supply due to demand changes. Then, we have expenditure awareness. Being fully aware and cognizant of what spending and cost drivers are happening with your business is critical. Having the ability to see, understand, and break down the current costs, predict future costs, and plan accordingly only enhances the cost optimization of your architecture in the cloud. Finally, in AWS, you can optimize over time with all of the tools and different approaches. You can measure, monitor, and improve your architecture from the data you collected in the AWS platform. Adopt a consumption model. With a consumption model, you pay only for the computing resources you use and then increase or decrease depending on business requirements. Essentially, trading CapEx for OpEx. The next principle is to measure overall efficiency. It is important to measure the business output of the systems and costs associated with delivering it. Then take this measurement to understand how gains are made from increasing output and reducing costs. Stop spending money on data center operations. With AWS, you no longer have to do the heavy lifting of racking, stacking, and power servers. We take that burden so that you can focus on your customers and businesses and projects instead of the IT infrastructure. Next, analyze and attribute expenditure. With the cloud, it is so much simpler and easier to accurately identify the usage and cost of systems. Customers can measure their return on investment, which provides them the opportunity to optimize resources and reduce costs. Finally, we suggest customers to use managed services to reduce the cost of ownership. The cloud has provided many managed services to remove the operational burden of maintaining servers for tasks such as sending emails or managing databases. And since this is all done on a cloud scale, they can offer a lower cost per transaction or service. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. In summary, here are the 5 pillars that make up the AWS well-architected framework. We have come to the end of Module 4. Please test your knowledge with these questions. An easy way to create a collection of related AWS resources and provision them in an orderly and predictable fashion. AWS IAM controls your users' access to AWS services and resources. Auto-scaling automatically adds or removes Amazon EC2 instances according to the conditions you define. With auto-scaling, the number of Amazon EC2 instances you are using increases seamlessly during demand spikes to maintain performance and decreases automatically during demand lulls to minimize costs. Moreover, you can consolidate all your accounts using consolidated billing and get tiering benefits. Is there a way to estimate the cost savings from using AWS versus on-premises environment? The Tco Calculator is a tool that has been developed to help you estimate cost savings when using AWS, use detailed sets of reports that can be used in executive presentations, and modify assumptions that best meet your needs. In addition, some benefits of the calculator include the ability of weighing the financial considerations of owning and operating a data center versus using a cloud infrastructure. Also, the Tco Calculator explains the assumptions and the methodology behind the calculations. So, go take a look. You can launch the Tco Calculator through https://awstcocalculator.com. We're going to introduce you to the AWS Tco Calculator. As a start, take a look at the URL which you can access this particular tool from the internet. This tool has a basic as well as an advanced option. We're going to stick with the basic option for now. You can select the currency from a list you see in front of you, and I'm going to select the Singapore dollar. You can compare against on-premises or co-location. In our case, we will select on-premises. And in my region of choice, the Singapore region. And I'm going to be comparing against a general workload. I'll put in some fictitious app name, Tco demo, put 2 virtual machines in my comparison, each with 2 CPU cores and 32 gigs. A list which I can select from: VMware, KVM Xen, Hyper-V. As for the guest OS, Linux. Next up, I will specify 100 terabytes worth of raw storage capacity for my SAN storage. And with that, click on Calculate TCO. And now we have the results of
the comparison between on-premises versus AWS. And as you can see here, you can save quite a bit of money over a 3-year period. We do a side-by-side storage, network, and IT labor. And we have a table on the right that gives you the actual numbers over a 3-year period. Some environment details. Again, you will notice that we do a side-by-side comparison for on-premises versus AWS. In this case, we're looking at the compute resource, and I'm selecting the M4 2x large, which is the closest fit per the configuration I keyed in earlier on. And I'm going to be using the 3-year partial upfront reserve instance pricing. The table below, EC2 instance mapping criteria, will make a lot more sense when I change the tool to take into account advanced requirements, whereby I'm going to optimize versus different criteria like CPU, RAM, storage I/O. Further down the list, I have a cost breakdown for compute, again, on-premises versus AWS, storage, and networking. Now notice for the AWS side of things, it's 0 because the AWS VPC service is offered at no charge to our customers. Now by clicking on the Calculations tab, we now have an even more detailed breakdown of server cost. Again, on the left-hand side is the on-premises cost versus what you do spend on the AWS side of things on the right. And we go into a lot more details, like things like server maintenance cost, the racks going to be used in your on-premises environment, rack infrastructure costs. We've included virtualization software costs because of the option that we have selected earlier, which is VMware. Now on our side, we have a lot more details breaking down the EC2 costs over a 3-year period. But now you have 2 numbers to compare against: on-demand versus reserve instances. And for reserve instances, we're using the 3-year partial upfront cost. Notice that we also include the AWS business support for these EC2 instances as well. Further down, we are also looking at on-premises storage costs versus that of AWS, and as well as the AWS business support costs for EBS volumes. Now notice that we also have included the backup cost comparison between on-premises and AWS. In the case of AWS, we're looking at the snapshot as well as incremental costs as you add more snapshots for backup purposes. And here you see the networking costs on on-premises environment. However, to complete the picture, we also include the cost breakdown for AWS support as well. Now, we can look at how we go about making those comparisons by selecting the Methodology tab. Under the Methodology section, we're looking at the acquisition costs and operational costs on on-premises environment, where we compare server, storage, network, and IT cost. Now, because some of you are actually using co-location environments, the cost structure is somewhat different, and hence that comparison you see. Finally, we have a comparison of AWS overheads side by side with on-premises environment. Right, this table you see in front of you, while we do include the AWS support costs, but that also includes services. And finally, as you can see here, we have a table that compares what you get by moving your workloads on AWS versus getting hardware on on-premises environment, which includes things like virtualization software, which is part of our service offering, but that's additional when you have to purchase it on-premises environment. Now this table here shows you the TCO calculation if we're comparing databases on-premises or co-location environments versus managing your own database running on EC2 instances, and finally versus running RDS, which is a managed service. If you have plans to move your Microsoft SharePoint workload on AWS, what you see here is the SharePoint architecture, which would be relevant had you selected a SharePoint workload as the workload of comparison at the start of this calculation. However, this is not complete if you do not know what are the assumptions made for cost comparison for on-premises, co-locations versus AWS. So in this list, we also include information like server costs from some of the well-known server vendors. We also include the host configurations, like, for example, the number of CPU cores and system memory. We also include software as well as storage assumptions. Network is not an afterthought. You definitely have to include that. What is sometimes forgotten is power, cooling, and IT costs that's associated with managing on-premises environment. Here are the lists of AWS assumptions, be it from a cost of compute, the usage of databases, storage, and networking. And again, if you're moving your SharePoint onto AWS, here are some of the assumptions made as well. And this is SharePoint Server 2016. If you want to find out more about the TCO, right, you can always take a look at FAQs, which list the most commonly asked questions about this tool. Most importantly, if you disagree with the assumptions made, you can modify them in this section, like, for example, the cost of hardware, storage, networking, licensing costs, and so forth. So that this calculation, this comparison, reflects your reality. This report can also be downloaded, and all you need to do is to fill in some of your personal information, and it will be emailed to you. Now, I'm going to show you differences between the basic and the advanced options for this tool. By changing a selection from basic to advanced, you notice that additional fields that appear under the server section, like, for example, the percentage of the VM usage, what are you optimizing by, is it RAM, CPU, or storage I/O, and the kind of virtualization host you're using an on-premises environment. And under storage, you can define how much of the storage is infrequently accessed, the kind of maximum IOPS expected to be used by application, and amount of data that's going to be backed up each month. So you can have a far more comprehensive look at your usage. We also include the network costs option as well as the IT labor costs as well. This rounds up a much more complete TCO calculation comparison between AWS versus your on-premises environment.
AWS wants to provide the right resources to support your success. So whether you are new or continuing to adopt our services and applications as your business solutions, we want to help you do amazing things with AWS. AWS support is there to provide you a unique combination of tools and expertise based on your current or future planned cases. With AWS, customers can plan, deploy, and optimize with confidence. If they need the support, AWS provides the tools and resources to guide them. If there's a user who would like proactive guidance, there are technical account managers or TAMs that are designated as their primary point of contact. The TAM can provide guidance, architectural review, and continuous ongoing communications to keep the user informed and prepared as they plan, deploy, and optimize their solutions. Your TAM is your advocate, your dedicated voice within AWS. For users who want to make sure they follow best practices to increase performance and fault tolerance in the AWS environment, there is AWS Trusted Advisor. AWS Trusted Advisor is like a customized cloud expert, but actually is an online resource that checks for opportunities to reduce monthly expenditures and increase productivity. If there is ever a need for account assistance, the support concierge is a billing and account expert who will provide quick and efficient analysis on the issue, freeing up the user's time to run their business. The concierge addresses all non-technical billing and account-level inquiries. At AWS, you can plan, deploy, and optimize with confidence. To support you, there have been specific support plans developed. Let's take a look at Basic Support. Basic Support Plan offers 24/7 access to customer service, documentation, white papers, and support forums, access to 6 core trusted advisor checks, access to personal health dashboard. Next, we have developer support. The plan offers resources for customers testing or doing early development on AWS, and any customer who wants access to guidance and technical support are exploring how to quickly put AWS to work. Use AWS for non-production workload or applications. For customers having production workload on AWS, we recommend using business support as a minimum. The plan offers resources for customers running production workloads on AWS, and any customer who run one or more applications in production environment, have multiple services activated, or use key services extensively, depend on their business solutions to be available, scalable, and secure. Lastly, Enterprise Support Plan. The Enterprise Support Plan offers resources for customers running business and mission-critical workloads on AWS, and any customers who want to focus on proactive management to increase efficiency and availability, build and operate workloads following AWS best practices, use AWS expertise to support launches and migrations. For more information and to compare the AWS support plans, go to the URL for more details. While the number and types of services offered by AWS have increased dramatically, our philosophy on pricing has not changed. At the end of each month, you pay only for what you use, and you can start or stop using a product at any time. No long-term contracts are required. Pricing information for each service on our website is available at http://aws.amazon.com/pricing. Our strategy of pricing each service independently gives you tremendous flexibility to choose the services you need for each project and to pay for what you use. As stated earlier, the Tco Calculator is there to help you estimate cost savings when using AWS. Detailed reports are available for comparing the cost of running your workload on AWS versus on-premises. You can also modify assumptions used to best fit your business environment. The support plans visited today were Basic, Developer, Business, Enterprise Support Plan. As discussed, all support plans provide 24/7 access to customer service, AWS documentation, white papers, and support forums, access to 6 core trusted advisor checks, and access to personal health dashboard. For additional technical support and support resources, we provide additional plans to fit your unique business needs. We have come to the end of Module 5. Test your knowledge with the following questions. Wrapping up today's course, we will look at what's next for you. The slide shows the current instructor-led training in the AWS Training and Certification Catalog. Classes are role-based and designed to be progressive as individuals gain deeper experience working with AWS services. The AWS Technical Essentials is our one-day foundational training on AWS services. Architecting on AWS is a 3-day course that teaches solutions architects to design and use AWS services on IT applications. Developing on AWS is a 3-day course to help individuals design and build secure, reliable, and scalable AWS-based applications. Systems Operations on AWS is a 3-day course focused on guiding individuals operate highly available and scalable infrastructure on the AWS platform. Advanced Architecting on AWS is a 3-day course that covers building more complex solutions which incorporate data services, infrastructure configuration, management, and security on AWS. DevOps Engineering on AWS is a 3-day advanced level course that demonstrates how to use the most common DevOps patterns to develop, deploy, and maintain applications on AWS. Security Operations on AWS is a 3-day advanced level course that demonstrates how to efficiently use AWS security services to stay secure and compliant. Migrating to AWS is a 2-day ILT that demonstrates cloud migration strategies and dives into our recommended 5-phase plan for migrating existing workloads to the AWS cloud. Big Data AWS is a 3-day specialty course that introduces you to cloud-based big data solutions and Amazon Elastic MapReduce, or EMR, the AWS Big Data Platform. Data Warehousing on AWS is a 3-day specialty course designed to teach you how to design a cloud-based data warehousing solution using Amazon Redshift. AWS certifications validate technical skills and knowledge necessary for designing, deploying, and operating solutions on the AWS platform. Earning certifications helps you gain credibility for proven experience working with AWS and contributes to your organization's proficiency with AWS-based applications. If you refer to the various training courses mentioned previously, those courses will assist you in your certification exam preparation. Why AWS certified? To the individual, being certified helps validate their expertise on the AWS cloud, while for employers, it helps identify individuals with the relevant cloud skill set and also help accelerate their journey to the cloud. Beyond attending training classes, there are many paid and complementary resources to aid you in your certification exam preparations. Begin your journey using the URL given in the next slide, which is www.aws.training. Please go to amazon.quicklabs.com. Once you're on the amazon.quicklabs.com login page, please click on Join to create a new account. After creating an account, please click on Sign In and log into QuickLabs using your login credentials. After logging into QuickLabs, please click on the menu option and then you can click on Catalog. You will find a set of quests or labs to choose from. A quest contains a series of labs based on technologies or services. Some quests even help prepare you for certification. You can alternatively choose individual labs by clicking on Labs. Under Labs, you will find labs with a title, the level of complexity, and the time required to complete the lab. You will also find the cost of each lab. As you can see, there are some labs that are free. You can search for a lab on any AWS service available by using the search options. Search for Amazon S3 and you'll find that there are a few labs on Amazon S3, one of which is a free lab. Please start by reading the lab overview to make sure you are interested to proceed. If you like to proceed, please click on Start Lab. Once a lab has been started, you can follow the remaining instructions. To log into the Management Console, click on Open Console. On the Management Console, you can verify your login and the region of the lab. Please switch back to the Quick Lab console to follow the remaining lab instructions. The lab starts with a list of topics covered. You start by creating a bucket, then upload an object. Make sure the right permissions are configured, and finally, enable versioning. First task is to create a bucket. Please follow the instructions on Quick Labs. On the Management Console, search for S3. You can then click on Create Bucket and enter a unique bucket name, such as lab-your name. If the bucket name is not available, please use additional characters for the bucket name. After you follow the remaining steps in the lab guide, you should be able to create a bucket in Task 2. You would upload an object, and then you would make the object public. After you complete the lab, please sign out from the Management Console, and on the Quick Lab screen, click on End Lab. Thank you for watching. This is the end of the Quick Lab demo. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. To recap, you can attend our AWS Qualified If you have watched all 5 modules, you will receive a set of attendance. Please look out for it after 1 week. We hope you found the conference interesting, and please take a moment to complete the feedback form. Let us know what you thought of today's event and how we can improve the event experience for you in the future.